This is part 1 of lesson 9.3, Polar Coordinates and Graphs. This lesson is going to give a review of polar coordinates and converting between polar and rectangular. And then we're going to start connecting it to some of our calculus concepts, such as finding tangent lines and max and mins. And we're going to build from there in the next lesson. So what we want to remember is when we use the term rectangular, we're talking about our normal Cartesian coordinate. We can also analyze things in a polar coordinate system where we have r and theta, where r is the distance from the pole, which is our origin in the Cartesian coordinates, and theta is the ray that you measure from 0. So it's our positive angle. This is our theta in that direction. So a point somewhere in space is labeled such as p equals 2 comma pi over 4. So that tells us we're 2 units from the center and or the pole, and that the angle that we have made is pi over 4. Please remember as well that you can also write this in different ways. There's more than one point that gives, or set of coordinates I should say, that gives you the same point. Like I could make this -2, so that would put it over here, and then to get the angle I want, I would have to say that the angle was, -7 pi over 4. So what that would do for me is I would come out from the pole in -2 direction, and then I would need to trace out a -7 pi over 4 angle, so that would move me over here. So there isn't a unique set of coordinates for one point like there is in the Cartesian system, because of the fact that we go around and we have periods and frequencies and things of that nature. Okay, so we are going to see our equations written in different forms, such as if we write them just as r and theta, we can also write them as f of theta. We can use parametric equations where x is going to be f of t cosine t and y of t will be f of t sine t, where t is our theta. So our x and y look like this in the box there. Now, one thing, I'm going to look at this again in a second, these right here are the conversion factors to go between x and y and r and theta. So we'll be looking at equations in both forms throughout this lesson. All right. So just a quick review of how we go back and forth. If we're going from polar to rectangular, if we're given r and theta, then x is r cosine theta and y is r sine theta. On the other hand, if we're given an xy pair and we want to change it into a polar pair, our r can be found by taking the square root of x squared plus y squared, and the angles formed by finding the inverse tangent of y over x. So our first examples are converting. So I'm just going to write the answers here since this is a review, and you guys can do these and then check your answers. If you have a question, I will answer them in class next time. So for both of these, we're going from polar to rectangular. So here are the 2 answers for those 2. So try them out and see what you get. And the same going the other way. So now we're converting the rectangular to polar. So here are the 2 answers for those. You can also write that angle as 5 pi over 3. Both would be correct for that. And for the last one, and again, this angle could be written as 7 pi over 4. Like I said, there isn't a unique set of coordinates for these. Okay, so give those a try using these conversion factors. This is something you should have done in pre-calc. So let's spend a little time converting polar equations back and forth. because while this is usually done in pre-calc, it's probably not done as much as it should be. Okay, so we're going to convert these rectangular equations to polar equations and then verify with a calculator. I'll leave the verification for you guys. So what we want to do is use our conversions to change these. So y can be written as r sine theta in polar coordinates. And then I'm just going to solve this for r. So r is going to equal 4 over sine theta. And I will check the first one real quick. So what you want to do is, if you have an 84, you want to go into mode, and you want to make sure that you change, which I've already done, change your calculator to polar on this line where the blinking light is. If you have an Inspire, you just go under menu, number 3, and choose polar as your option to write your coordinates. So when you do that, what happens is when you go under y equals, you now have an r equals, and your variable key will put theta in. So we have this equation then we're putting in 4 over sine theta, and it should be a horizontal line at 4. Oops, I forgot to reset my window. Sorry about that. And there we go. So that's how you're going to check them. Now normally the way you see a line is it'll be simplified to be 4 cosecant theta. All right, so the next one, we have x and y in this, so we'll change y to be r sine theta, and x will be r cosine theta, and then we have the plus 2. So now we have to solve for r, so we're just going to use a little algebra. So I'm going to factor out an r, and at the same time I had moved the cosine term to the other side, so now I can get r equals 2 over sine theta minus 3 cosine theta. So that is the equation of a slanted line. Usually has this form in polar coordinates. Okay? And then finally, what does a parabola look like in polar coordinates? So in this case, we're going to start again by changing y and x into r and theta. And then what I'm going to do is divide both sides by r because I don't want r squared. So I have sine theta equals 2r cosine squared theta. Get r by itself. So I'll have sine theta over 2 cosine squared theta equals r. And now I can just rewrite that into a different form. So I have the 1/2. Sine over cosine is tangent. And then I am left with 1 over cosine, and that is secant. So here's the normal form of a quadratic in polar coordinates. Okay, then going the other way, we're going to work backwards. So I want to get everything in terms of cosine and sine and r, so I can switch them back to x and y. So what I want to realize here is that for this one, I really have negative 3 over cosine theta since I have a secant there. So when I move the cosine to the other side, I have my x right there. So this is a vertical line. And I'll check that one as well. So I'm going to go in here, and you can check all these because you know what they should have looked like to begin with. So this should be a vertical line through x equals negative 3. So I'm going to type in here, I'm going to put, since I don't have a secant key on the 84, but you do in the Inspire if you're using an Inspire, negative 3 over cosine theta. And hopefully this will be a vertical line through x equals negative 3, which it is. All right, so doing the other ones. So the next thing, I don't want a fraction here, so I'm going to have r plus 2r cosine theta equals 4. So now I have r plus 2x equals 4, so I'm almost there. But what I want to remember is I don't want any r's at all. So let me do this. Let me solve for r. and then I can use the r conversion. So if I square both sides, I get r squared equals 4 minus 2x squared, so that r squared is x squared plus y squared. And I can expand this if I want, and I get 16 minus 16x plus 4x squared. And now you can solve it for y, but normally when you have x squared and y squared, you usually put everything on one side. You put it in standard form. So what we have is, I'm going to make it so the x squared is positive. So I have 3x squared minus 16x plus 16 minus y squared equals 0. I'll just leave it like that. And if you want to see what shape that is, go ahead and verify it. Okay, and then finally the last one, it would be very similar to letter B. We're going to get rid of the denominator. This one's a little easier because then we're going to distribute the r and we'll have an x and y. So this, if you notice, looks a lot like letter B that we just did. It's a slanted line. So we have r cosine theta plus 2r sine theta equals 3. So now we have x plus 2y equals 3. And if I want to, I can leave it in this form, or I can solve it for y, put it in y equals mx plus b. So I have 2y equals negative x plus 3. So y equals negative 1/2 x plus 3/2. So you do have a slanted line. All right, so I'm going to do a little bit with polar graphs, and then we'll move from there. So we're supposed to describe what you know about the graph of each polar curve, then convert the polar equation to a rectangular equation, and sketch the curve on the grid. So all we know is we have an r of 3. So if we were to go out on our polar graph here to where r is 3, what we would have is, with no angle given, we would just have this graph. And that, of course, is a circle. And it's centered at the origin, or the pole, since we're in a polar coordinate system. And it has a radius of 3. So if I convert it, that's what I should get. So r is equal to the square root of x squared plus y squared, and that equals 3. So if I square both sides, I get x squared plus y squared equals 9, which is exactly what I expected. Okay, next one. Negative 3 sine theta. So what is that going to look like? This is also going to be a circle, but it's not going to be centered at the origin. It's going to be offset a little bit. So how is this going to look? Since we have a negative sign there, it is going to be shifted down. So it's going to look like this. So it's going to be centered at like 1.5. Oops, I forgot to press my little finger thing there. And it's going to go kind of like that. It's not my best circle ever. It's more like a Squidward circle. So it's going to look something like that. Okay, so to convert this, I'm going to multiply. I need to get an x and a y in this somehow. So I'm missing an r here on this side. So I'll multiply both sides by r. So now I have x squared plus y squared equals negative 3y. And now what I can do is use completing the square to put this into the form of a circle. So I have x squared plus y squared minus 3y, or plus 3y equals 0. Completing the square gives me this. X squared plus y plus 1.5 squared is going to equal 2.25. You guys can fill in the details for that. So you can see this is centered. This is a circle, and it's centered at 0, negative 1.5, and it has a radius, take the square root of that, of 1.5. Okay? And then finally the last one. For this is going to be a vertical line, because we just did one like this. We just did this. It was letter A of number 4. So this is a vertical line through x equals 5. So to verify that, what I'm going to do is multiply both sides by cosine theta, and then this becomes x equals 5. So it is going to look like this. Okay, so I'm going to stop here and continue our discussion in the next video.